could start today's webinar, which has to do with smart communities, and the contents of the webinar today concerning the UoA's presentation has to do with the development of smart and nearly zero energy buildings protocols for Europe. So the objectives are the analysis and the identification of the three major problems of the built environment, which are the energy consumption, energy poverty, and local climate change, a set of a roadmap which involves future quantitative and qualitative targets, investigating the major technological, economic, and social forces and policies, the identification of the links, the synergies, and the impacts, and the interrelated nature and characteristics of these three sectors, the benefits for the society, including the impact of the economy, employment, and environment and health, and the conclusions. So, in order to start the presentations, the major problems, as we mentioned before, of the built environment in Europe is the high energy consumption, the local climate change, and the energy poverty. Concerning to the consumption, buildings consume almost 9 petawatt-hours and represent up to 41% of the total consumption. The European building stock is close to 24 billion square meters, and almost 75 of them are residential buildings with an average floor space which is close to 19 square meters per dwelling, while the rest is tertiary buildings. Almost 27% of the total energy consumption in Europe is spent in residential buildings, and the rest of it is consumed by the tertiary sector. The average building energy consumption in the European Union countries varies between 320 kilowatt-hours per square meter and per year in Finland, and 150 kilowatt-hours per square meter per year in Bulgaria and Spain, while a mean value is close to 220 kilowatt-hours. There are large differences in energy consumption exist between residential and tertiary buildings. Dwellings consume on average almost 200 kilowatt-hours, while the mean consumption of non-residential buildings is close to 300, let's say, kilowatt-hours per square meter annually. The energy consumption in tertiary buildings is increasing constantly, has a constant increase during the last 30 years, and the increase rate is 1.1% for the years 2010 to 2020, which is quite important. The increase of the energy demand is because of the evolution of the services sector that has increased by 1.3% per year. And services will be responsible for a huge amount, 93% of the additional energy to be consumed by tertiary buildings between 2000 and 2030. So trade and office buildings are the largest energy consumers, which account for about 26% of the global consumption of the tertiary buildings, and space heating seems to be the end use presenting the higher energy consumption. Energy spent for heating represents a constant increase over time, which is a result of the important energy conservation measures applied in tertiary buildings. In residential buildings also, the energy consumption is increasing constantly. And this happens despite the strict legislative framework and the significant improvement of the energy efficiency. It has increased by 14% between the years of 1990 and 2012. The electricity use has increased by 60%, and this is because of the very rapid penetration of devices and electronic appliances. Final energy consumption in the residential sector in the European Union had a very significant number in 2010, while it has been decreased, while the corresponding consumption of the previous year of 1990 was less, was 273 this value was for this year. The increase of this energy consumption is attributed to various economic, social, political, and technical reasons, and a main reason for this is the increase of the number of households and the increase of the occupied space per person. The energy consumption also for heating is increasing constantly. Although the total energy consumption of buildings has increased, the specific consumption for heating purposes has decreased to about 15% during the period of 1997 till 2009. And this may be attributed to the considerable lower consumption of the new buildings, because the new buildings after 1997, which represent almost 20% of the total dwelling stock, has been built with better directives and better legislation. So there has been a decrease in the energy consumption for heating. So the new buildings consume almost 30 to 60% less thermal energy than houses that were built before 1990. Dwellings built in 2009 in Germany represent almost 58% less energy consumption than those built in 1990. And these corresponding reductions in Sweden, Slovakia, and the Netherlands are at about 50%, 55%, 53%, 52%, and 50% correspondingly. The impact of the economy on the energy consumption of buildings. The energy consumption in the building sector is subject to significant economic, environmental, and social factors. Past and present experience demonstrate that it is an extremely sensitive sector, presenting a high variability in economic and environmental variations, and financial problems oblige part of the population to consume less energy and satisfy partly less needs. It is characteristic that during the financial crisis of 2007 to 2012, the energy consumption of the residential buildings was decreased by 4%, while in countries which had a deeper economic problem like Portugal, Slovakia, and Ireland, the decrease was 16%, 22%, and 22% respectively. And this is characteristic because of the serious economic recession in Greece, and the consumption of the heating oil was reduced by 68.7% in just 1 year. Concerning the local and global climate change, which has a serious impact on the energy balance of Europe, the climate change, which is the third factor of the three major ones that we mentioned before, is a major issue for Europe, of course. The increase of the ambient temperature and the higher frequency of the heat waves have an important impact on the energy and environmental quality of the built environment and increase the vulnerability of the local population. And given the fact that 74% of the European population lives in urban zones, it affects a very significant part of the European population and has a serious impact on the global energy and environmental quality of the built environment. So higher urban temperatures increase the energy consumption for cooling. This is well known to everybody. And raised concentration of pollutants deteriorate the thermal comfort conditions and create important health problems to vulnerable population. In this diagram, we see the annual average urban heat island intensity, which varies between 0.1, let's say, and 2 degrees of Kelvin, with an average value close to 1, 0.8 Kelvin, and the average maximum varies between 0.3 and 6.8 Kelvin, with an average close to 2.6, let's say. And we see that in parallel the average maximum and the absolute maximum urban heat island intensities for all the experiments and for all the cities that we see here, which has to do with measurements based on standard fixed stations. We see all the intensities on the non-standard sections, which we can see here. So the impact on energy based on different scenarios and forecasting of cooling degree days shows an increase in, let's say, an increase for the years of between 1960 to 1990, and a major increase up to the years of 2091 to 2100. Concerning the health, we see that for the apparent temperature, there has been a correlation. It's not very clear now in many cities, but there has been a trend. It is just a representation here, and there is a publication that I can send to you after this presentation that has to do with the correlation of the apparent temperature and the mortality rate, which is apparent that according to different cities and the increase of the temperature, there has been a strong correlation with the mortality rates of the population. Concerning the energy poverty, it is clear, and it has been stated that there are almost, let's count here, the zeros. There is a large number of population which is energy poor in Europe. Energy poverty is actually a threat in Europe, and it is actually the situation in which the household lacks a socially and materially necessitated level of energy services in the home. Energy poverty is a problem of a vast population in Europe, 150 million, which are unable actually to pay the bills and maintain comfortable standards. This is particularly valid for the citizens of the states with GDP below the EU average, where over 30% of the population face energy poverty. And this has a very serious impact on the quality of life of the citizens, affecting indoor comfort conditions, social attainment, and health. And it is a result of combined factors like the insufficient family income, the poor quality, and the low size of the house, and the possible high energy prices, while some other demographic drivers may play also a very important role. Almost 10% of the European Union population live in houses with important energy problems, and according to the European statistical data, 10% of the European Union population live in houses with important problems, while corresponding percentages increases actually to 25% for the low-income groups. And other data, of course, reveal that about 20 to 55% of the lower-income households in Eastern and Southern European countries live in dwellings with leaking windows. In the UK now, about 17% of the poorest families live in houses with serious despair, while low-income population live in dwellings with mold and condensation, 3 times more likely the high-income population. In parallel, there is a major number of houses that suffer from excess cold, which is actually about the 8% of the dwelling stock in the UK. Here in this diagram, this figure, let's say, introduces a more comprehensive view of specific interconnection and influences. There is a relation, let's say, between low and zero energy consumption buildings and the global and local climate change, and this seems evident. So, however, there are synergies and the specific impacts between the subject, which has to do with global and local climate change and improving the building stock and decreasing the energy consumption. So these synergies has to do with, firstly, the low energy consumption, which decreases heat emission from the HVAC systems and power plants and reduces the total anthropogenic heat and CO2 emissions that are released in the atmosphere. A second link has to do with the increase of the energy efficiency of buildings, which will decrease the cost of the energy services and may result in an increase of the consumption, which has to do with the rebound effect. Third link has to do with fuel shift for conventional to renewable energy sources, which will result to decreased gas emissions. Fourth link has to do with higher ambient temperatures that increase the energy consumption for cooling and decrease energy for heating. Higher ambient temperatures and heat waves increasing the peak electricity demand and oblige utilities to build additional power plants which operate for reduced time periods, and also they obliged additional electricity transmission infrastructures. And this, of course, this results in increased cost of supply energy. Sixth link has to do with climate change that creates increased energy and environmental needs for dwellings of the elderly and vulnerable population, which leads to the urban heat island increases the size of the HVAC systems and rises the capital investment cost. The eighth link has to do with the urban heat island that increases the concentrations of ozone in the atmosphere and obliges for additional mechanical filtration and ventilation systems and higher ambient temperatures that decrease the potential of passive cooling techniques like night ventilation. So this, in the idea of zero concept world, involves an innovation to zero strategy for all technologies that are related to emissions, waste, defects, etc., etc. The ultimate goal of this whole concept is to develop zero emissions and zero waste technologies applied to zero energy and zero emission buildings and cities, where advanced and innovative technologies and policies will be applied to minimize crime and diseases. Although such a concept seems to be very radical and perhaps opportunistic, this idea incorporates some exceptional features of development of, let's say, a roadmap that makes it practically attractive. So the setting of the future goals of innovative to zero in the means of zero energy consumption, zero climatic change, and zero energy poverty has to do with the energy consumption in buildings, the impact of the construction sector on the local climate change, and the possible levels of energy poverty to zero. This needs, of course, a very ambitious vision to proceed, and it has to set some clear and ambitious future goals, and certainly it will be achieved gradually. So even the attainment and the satisfaction of some of these goals will be a major success, and progress for the society, and the adoption of and achievement of the specific objectives require planning and follow of an innovative scientific and political agenda which will be full of technological breakthroughs. This, of course, involves a significant investment in the construction sector, which will create substantial opportunities for the future and will certainly cause major and medium and long-term benefits for the society while alleviating the population by the intensity and the consequences of the problems that they were mentioned before. This diagram presents, in a comparative way, let's say, it is the cumulative expenses and required costs per petawatt hour of energy conservations predicted by several scenarios for 2050. It reports the calculated investment cost, and in all these studies we can see that the required investments in petawatt hour of the energy reduction show an increase as a function of the targeted energy reduction, and the higher the achieved total energy conservation, of course, the higher the required investments per unit and energy gained. And this is because of the, let's say, incremental cost of energy technologies, which is increasing when most, let's say, sophisticated systems have to be employed in order to minimize the energy consumption of new buildings and in order to perform a deeper, let's say, renovation in the existing stock. And this is the energy conservation, according to the previous diagram, the increase of the energy conservation, of course, with the increase of the cost. So the cumulative investments to almost minimize the energy consumptions of the building sector in Europe by 2050 should be around 14 to 23 trillion of euros, and the CO2 emissions of the residential sector in 2050 will be reduced by 90% compared to 2005, while the corresponding decrease of the tertiary, this is always a very difficult word for me to say, I can never say it, which is close to, Aphrodite is correcting me right now, is close to 87%. The application of energy efficiency measures has, of course, a positive effect on employment and the number of additional full-time jobs created in Europe per 1 million of euros invested, and varies between 6 to 39%, with an average value close to 80.9 jobs per million of euros, which are invested. Well, of course, the minimization to zero of the energy consumption has to do, of course, with smart systems and smart buildings that provide optimal management of the energy resources in the building, while they satisfy all comfort and sanitary requirements, and all the advanced ICT technologies, when applied to buildings, they can coordinate and network the energy-related components in a more holistic way. For this diagram, we can see here the required investments, the expected energy reduction, and the new full-time jobs to be created in the three considered sectors, the policies and the actions. One sector is the minimization of the energy consumption of the building sector. The other details that we will see afterwards has to do with the mitigation of the urban heat island as a policy or an action, and the other action is the eradication of the energy poverty. So as I mentioned before, this full information can be given through a publication that I can distribute to you later, which has to do with all these policies, actions, investment, and the other benefits. Now, the policies aiming to minimize the energy consumption of buildings should concentrate on three main technological axes that aim to increase the global energy efficiency of the building energy systems in order to decrease the energy load and final needs, to supply the remaining energy load through clean and renewable technologies, and to optimize the management of the energy and environmental systems of the building through the use of smart and intelligent technologies, as we mentioned, of course, before. The intensive research has permitted to develop various technologies that help to mitigate and minimize the amplitude of the local climate change. Among the most promising technologies are those aiming to increase the albedo of cities. Highly reflective materials used on roofs and or in the pavements to reflect solar radiation and avoid absorption of solar heat, and technologies are well known as cool roofs and cool pavements, respectively. And a variety of highly advanced reflective coatings and materials have been developed, presenting a very high reflectivity in the solar spectrum together with a high emissivity value. Cool roof systems are extensively used around the world, and their capacity to mitigate urban heat island is, of course, well documented. In this diagram, we can see the calculated total investments in order to install cool roofs and cool pavements in some selected European cities. Here in this diagram, we can see the calculated total investment per person in order to install cool roofs and cool pavements in these selected European cities. And here is the other table that I mentioned before regarding now the action and the required investment, energy reduction and full-time jobs, and other benefits concerning the action of mitigation of the urban heat island. So eradicating the energy poverty, the energy rehabilitation of the homes that are occupied by the lowest income households, this is the more efficient policy to fight the energy poverty and to protect the vulnerable population. So a deep retrofitting of the building stock used by the energy poor in Europe could have very significant social, financial, and environmental advantages. So to estimate the possible benefits from such a policy, the necessary investments in order to minimize their energy consumption as well as the existing housing conditions have to be known, or at least they have to be estimated somehow. And given that energy poverty is not approached in a common way in Europe, there are convergent assessments about the total amount of the energy poor. And here, what we can see is the cost of the various scenarios, of different scenarios on the rehabilitation of the low-income houses in Europe, and the actions and the details concerning the eradication of the energy poverty. Concerning the high energy consumption of the Europe sector, the local climate and energy poverty are the major problems of the built environment. in order to conclude, let's say, and these three sectors are strongly interrelated, as we analyzed before, and they present very significant synergies and trade-offs. The existing policies aiming to reduce the energy consumption of the buildings usually underestimate the importance of and the impact of the local and global climate, as well as the technical, social, and economic implications related to energy poverty. So a failure to consider all the issues in an integrated and holistic way may inevitably result in higher energy consumptions and social discrepancies. So innovative to zero, the built environment of Europe assumes a minimization of the energy consumption of buildings, the eradication of the energy poverty, and the mitigation of the urban heat island and the local climate change as three factors that are very strongly related together. So such an objective, although it seems ambitious in an unequivocal choice that will create substantial opportunities for future growth and will alleviate the population from the consequences of the specific problems and will create short, medium, and long-term benefits and opportunities. So, thank you all for your attention.
Thank you very much, Theoni. I think we can now switch to Professor Artopoulos from Cyprus Institute.
Nikos?
Yes.
Is there any questions about the presentation? Anything to discuss about the people that attended?
Would you like to have questions now? Or?
Because we had this presentation. Okay, if you want to have it at the end, it's okay for me. Okay.
It's not a problem for me either.
No, it's okay. It's okay. Let's have it at the end.
Okay.
Okay.
Sorry, I'm trying to...
No, I'm
yes.
Okay, good. Okay, I'm the presenter.
Yes.
Great.
Thank you.
Yes,
please.
Okay. Hello, everyone. My presentation today will look at the same broad issue, but from a totally different point of view, and I hope you will enjoy it, coming from a more humanities background rather than a technical one. Social media and digital technology surrounds us. We are moving into an age of ubiquitous, that is, everywhere computing. New media and information and communication technologies already impact on many aspects of everyday life, including work, home, and leisure. These new technologies are influencing the way that we develop social networks, understand places and location, how we navigate our cities, how we provide information about the utilities and services, develop new ways to engage and participate in our communities in planning and governance and other decisions. My presentation today will look at smart urban open spaces. We will talk about some of the uses of ICT in open spaces and give a description of the combination of innovative technologies in cityscapes. We will briefly see some, we will browse through some typologies of open spaces relating to urban environments. We will see the relevance to sustainable development of communal spaces. We will discuss about how can ICT contribute to a better understanding of needs and requirements on public spaces from a user's perspective, looking at the communication medium, various outdoors activities and the social function of public spaces. We will discuss about some principles, and we will see some examples of intersection of ICT and public space. And then we will move on with what is the contribution of the various disciplines in the field and how they should work together in the process of making better public open spaces. And we will conclude with some remarks. The main question raised in this presentation is, Can we utilize the developments in technology to inform change in the way places are designed and built to work together with urban design and the physical urban infrastructure to develop socially cohesive, livable, sustainable environments? This presentation addresses 4 areas of how ICT impacts on the urban form. The first area is the layer of digital information, that is augmenting space. The second one is by means of physical installations. The third, by means of social networks and communication. And lastly, via community participation in planning. As a result of current research and development of ICT, there have arisen a number of different ways in which information and communication can be shared. Terms like ubiquitous computing, augmented reality, tangible interfaces, intelligent buildings, context-aware computing, ambient intelligence, smart objects, wireless location and sensor networks are just some of the terms we are coming to grips with. Professor of Computer Science at the City University of New York, Lev Manovich, suggests that the end result of development in all these areas is the same: overlaying the physical space with the dynamic data. In varying degrees, this additional data layer is changing the relationship between people and the spaces they inhabit, and this will in turn impact on the shape and development of urban form. For several decades, the relationship between technology, creativity, and city life has been an intimate one. Following creative city policies, popular in the late 90s, smart city business, policy, and design visions have gained considerable traction. Among the issues that smart city policies seek to address are mobility, clean energy, water and food production and distribution, health, living and public participation. However, among cities such as Rio de Janeiro, Barcelona, Amsterdam, Masdar, and Sogdo, the emphasis and actual implementation of smart city visions differ hugely. We can see here a few typologies of open-air spaces like greenways, waterways, meadow, woodland, playing fields, churchyards and cemeteries, allotments, urban allotments, park, green spaces, piazzas, squares, playgrounds, communal gardens and private gardens, courtyards. All these spaces obviously can be used to enhance the cohesion of smart communities. Smart city visions have received wide criticism. By and large, this criticism has focused on the ill-defined notion of smartness in smart city visions, targeted the simplified view of what cities actually are, and attacked their apolitical technocratic nature. What does smart mean, and who are actually supposed to be smart? Is city life and the urban experience about control, efficiency, and predictability, or about encountering the unexpected and dealing with differences? Moreover, smart city views propose technological fixes to complex problems. Many so-called smart technologies or smart interventions are implicitly driven by logics of consumption, control, and capsularization, but do not empower citizens to become active players in their cities. The push for safety with CCTV and smart risk assessing algorithms turns cities into places of pervasive control and surveillance. Smart retail solutions, location-based services, and predictive algorithms push a consumerist view of urban life. Also, personal mobile technologies foster a culture of capsularization and retreat. When technology-driven solutions ignore active contributions of citizens, they may have adverse effects for urban public life and identities at large. Cities face ever more complex issues. This requires smart strategies to tap into the pool of citizen wisdom and participation. In attempting to define interaction from a human-centered interaction perspective, As the way people use, understand, and experience products, services, and situations, it becomes clear that understanding the future of smart communities is not straightforward. Within the complex levels of interaction, the character of the user is changing. Users are diverse, multiple, made up of different groups, and targeted differently. Users are part of different multiple communities simultaneously, with multiple stakeholders, investors, policymakers, and actors involved. They might be more active in one phase of a process over another, and might have different and conflicting interests. Their collaboration becomes networked and involves connecting with an array of heterogeneous networks. The focus is increasingly placed on an entire ecosystem of tools, services, systems, products, their environment, or their resulting outcomes. The impact on the personal, social, and urban level implies that products and services are no longer only products and services, but may be subverted by the user to their own end. The increased complexity of the development of urban product service systems goes hand in hand with complex heterogeneous actor networks. The interplay between people and network tools, the ability, concerns, and practices of people, and the properties and behavior of products within this urban context is becoming increasingly complex. They are part of the urban ecology, the city as a series of platforms for urban interaction. This presentation discusses how technology can be used to activate people using public space in settlements and cities in order to go out of their houses and use common facilities for interaction, socialization, information exchange, playful use of the urban space, exploration of the outdoors, and economies of scale. After the Second World War, Dutch architect Aldo van Eyck dotted the ruined cityscapes in the Netherlands with outdoor playscape spaces as a way to counter top-down functionalist planning policies and open up room for people's own creativity. If we want citizens to be smart alongside cities, we need to better understand how people are already smart in a multitude of ways and how we could leverage this to make better and more interesting cities. Some questions that arise are: how can ICT contribute to attract more users to engage with public spaces more efficiently, enhancing their health and well-being at the same time? What is known about the relationship between new media use and spatial practices? What do people want from public space? How these differ by socioeconomic status, gender, age? The attributes of smart community systems, in accordance to the Smart Cities Initiative, could be defined by the use of sensor technologies in a connectable space, accessible to the public through ubiquitous technologies, used in sociable and shareable ways, where the virtual is made visible or augments the landscape. ICT can be used in this context to give or gather information, to aid co-creation of space, to allow crowdsourcing of information and opinions, and to allow effective sharing or self-monitoring of activities. Hardware may be embedded in the environment in the form of responsive sound or lighting systems, control systems, kinetic objects or artworks, passive sensor technologies, and display systems. We recognize that the use of such affordances will be qualified by such considerations as the time of day, the duration of the visit, the weather and temperature, location, season, individual or group engagement, age, gender, purpose of visit, and the topology and size of the space. It appears evident that different actors, designers, city makers, artists, geographers, economists, sociologists, anthropologists, among many others, are linked to or moving toward an increasingly overlapping set of approaches using all sorts of qualitative and quantitative research methods in both analog and digital forms, in virtual and physical applications. social and technical layers are looming over the city, altering the interactions within it. Transforming the interactions among the city actors and agents requires a transdisciplinary approach and a suitable language that allows this work to be done. This process challenges existing conceptions of urban space and demands new and shared vocabularies to fill in the gaps that appear between systems and disciplines. This effort weaves together physical space occupation and use and smart cities technologies, thus paving the way for more efficient implementations of governance concepts like inclusive smart collection of feedback by stakeholders, as well as for new opportunities for citizens in smart cities implementation. With regards to technological disciplines, problems arise around the limitations and possibilities offered by each tool or system that determines the way interactions take place in urban space. Technologists are now repositioning their thinking about how they design tools that can actually change urban interactions. The importance of this development, as we will see in the examples that follow, is that for a large part they try to put technology in the background while foregrounding the many human-centered perspectives strongly influenced from the traditional design disciplines. What these physical installations offer as new and innovative is that they add an element of entertainment and fun to public spaces, bringing life and social interaction for inhabitants. For example, the Hole in the Earth project allowed people from opposite sides of the globe to interact and communicate in real-time, serendipitous and entertaining ways. One hole was set up in Rotterdam, while the opposite end of the tunnel was set up in Shanghai. A webcam and audio stream internet link was established between the two. This global connection between two cities of different culture and language, besides providing intrigue and fascination, has potential for building community-based interaction relations, although the development of relationships on the same side of the globe, based on the whole, as a talking point is much more likely. The challenge for the urban designer or planner is to manage to blend these technologies in the urban fabric so they do not disturb the form and visual amenity of their setting. Too often, they are placed as dominant animated billboards with no sympathy to their location and context. Another example focusing on ludic performances in the city is the awarded Shadowing project, an interactive public artwork involving shadows captured from passers-by, which interact with people who follow. Winner of the 2014 Playable City Award was installed in Bristol, UK. Shadowing used infrared technology to capture people's outlines, then project movement back as shadows once the people who had formed the shadows have moved on. The project was designed to explore the disconnectedness that technology can create between strangers, the role light can play in creating a city's character, and the unseen surveillance culture that pervades contemporary urban spaces. Another project is the one you see here in the presentation. The vision of this was to facilitate citizen dialogue about the spatial urban environment and allow citizens to furnish the public urban space. The project consisted of digitally interconnected and tangible building blocks that citizens could use to construct their own designed urban architecture proposals. These building blocks required a continuous usage by citizens to sustain their digital life and reason for existing. Another interesting example is La Voix. It was designed and produced by a French startup company which developed this as a wind turbine inspired by biomimetic understanding, and in particular from trees. Two of them are already installed in Bretagne. You see the photograph. This was taken from the website of the company. Advantages in terms of design, that it is silent, durable, and relevant with the urban environment that it was installed, and the equivalent of the energy produced by it. Yet another example, which is designed for Paris, is the Escale Numérique, which translates as digital break. And it was inspired by the city's 19th century network of drinking fountains. Escale Numérique taps into an underground fiber optic network to provide the fountain of free Wi-Fi in a heaven of quiet on a busy city street, comprising a large touchscreen protected by a sustainable green roof covered with plants and concrete swivel seats with mini tables and an electricity supply. It heralds the kind of thing that could be achieved on a larger scale. Another interesting example is the CO3, which is a physical installation shaped like a swirl plant. The installation has a CO2 sensor measuring the surroundings, and depending on the concentration, the tree will either wither or grow. The leaves will change shape and color. The measurements determine the life of CO3. That way, the presence of the viewer has a direct impact on the life of the CO3. Normally, it wouldn't be possible for the human eye to see the impact of CO2 on our environment, but CO3 makes it visible. The viewer sees a part of reality that hopefully will be hard to forget. After this brief overview of physical installations, another area where ICT can empower citizens is that of social networks and communication, and the use of platforms like Facebook to promote landmarks is an activity that can clearly benefit tourism and local economy. And this is a very famous example where basically we can see, based on the number of appearances in people's pages and likes and discussion, the most famous landmarks arranged by city. And lastly, in our list of areas of interest is community participation in planning. Online community participation forums have become common over the last decade, with most councils and government bodies offering an online feedback mechanism. The extension of this type of feedback and citizen engagement is the subject of the current research project Discussions in Space at Queensland University of Technology, working with Brisbane City Council, is looking at ways of providing forms of in-place digital augmentation, which refer to the ability to enhance the experiences of citizens in physical spaces through digital technologies that are currently accessible within that space. In this experimental project, large public screens were utilized to facilitate the discussion of topics related to the development of the Brisbane City Blueprint. Passers-by were able to interact with the screen by messaging through their phones, SMS, Bluetooth, or Internet, Twitter and email capabilities. The large screen interface invited comment and share opinions on a range of civic topics, providing a platform for collective expression and public discourse amongst Brisbane residents. Another urban interaction design paradigm is an annotative research project initiated by the informal urban remediation project named Green My Favela. This project was created to map the garbage that wends its way ubiquitously through Rio de Janeiro's Rosina favela. Drift Rosina, as the project was called, was created in early 2013 using the Motion X iPhone app to track, plot, and gather data on the garbage problem in the favela. Green My Favela photographically geotagged the critical garbage sites where trash built up has reached critical proportions. This process involves speaking with the trash pickers already working at several points along the way to gather information about how trash could be collected and recycled, what type of trash were most profitable to be recycled, and how it should be sorted. The GPS-tagged photos were marked as wayfinding points on a Bing map, and the information was used to identify potential recycling sites. Since the Industrial Revolution, society and culture have been subservient to technology. One of the compelling tasks today is to reverse the process and make technology serve culture and society. With regards to data aggregation, many so-called smart city visions rely on the aggregation of all kinds of data about urban life that can be used by companies and governments to offer various urban services, from traffic management to street lighting schemes that save energy. Meanwhile, many cities have already embarked upon open data schemes, giving citizens access to governmental datasets. However, while these datasets may be valuable for citizens with particular skill sets, for most citizens, sets of numbers and commas do not mean anything. They might have a formal ownership over the data platform, but they might not be able to take active ownership over it because they lack the skills necessary to understand or act upon the data. To what extent do designers also need to take this more active ownership into account? Do they need to offer programs that make datasets intelligible, operational, and exchangeable for citizens? And on another level, to what extent do governments or designers need to give citizens a voice in the organization of the metadata? The discipline of urban informatics and human-computer interaction offers the urban planner a range of potentially significant opportunities. From the development of regional and global economies to the design of our civic and community spaces, the digital age is influencing the urban form. Our public spaces learn. Their design is part of an evolutionary design process, and these places need to be adaptable, flexible, and enduring in order to serve the community well. The message for designers is not to sit back and let a human-computer interface have all the fun. Designers can have an active and meaningful input and participate in the area of new media and ICT in order to make these places even more animated, enjoyable, and to build socially cohesive communities. Thank you.
Thank you, George. I would like to thank both George and Theoni for their excellent presentations and the fresh ideas and perspectives that they gave to the group. I would like to open the floor for discussion now and questions. Are there any questions?
Yes, Denia. I would like also to thank George for this presentation. It was very, very interesting, and it gave us another point of view for the application of these technologies. So I would like to ask about the application in open spaces of ICT. For example, this shadow project, which I personally loved. I found it very interesting, and all the other projects too that you presented to us. Do you have an estimation about the way that people, the public, was informed about this application and how these applications were accepted or appreciated by the people? Did they have let's say, a good level of acceptance and of using these applications?
To tell you the truth, the only example of which, of all the examples that I presented, the only example that I know personally people involved in the production of the installation, so I can tell you from first hand how it was accepted is the one at Bristol, the shadowing, which was
which was the one I preferred.
received.
Okay.
Sorry, excuse me.
Yes, which was the one that I preferred most. Okay, so tell me
Okay.
about it.
This one was very well received, obviously mostly from younger generations, and it was on for almost half a year, for almost 6 months, and I know about this project because the interest of of its creators wasn't only in setting up this interface, but mostly in evaluating its impact on the citizens. So basically, they would keep track of all the people that for how long time they would they would interact with the shadow, what times of the day they install it in different areas in Bristol. They would move it in basically through this period of 6 months. They would install it in different roads to see to evaluate and assess based on the kind of citizens that the inhabitants and their status, their economic status, the average income they have, to see who is if they could extract some better understanding of its impact. And from what I know, there was a curve. There was a curve of interest, learning, playing with it, and after a couple of months, the interaction level would basically hit a plateau and would stay the same.
Okay.
For the others, I really don't know. The tree-like turbine, I think it's doing well. It is well accepted from the people.
Okay.
From what I could say from the website, from what I could gather from the website, it's not that I know them personally.
Also, George, was it part of this Bristol being the green capital of Europe? It wasn't in this context, this work, because
I don't know. This was back in 2013. In Bristol, they invest heavily in smart technologies. The municipality, the city of Bristol, has.
Is also the European Green Capital for 2015.
Okay, so maybe yes, maybe it was related.
Yeah. Okay, thank you, Theoni. This is for your comments and for. Are there any other questions from any other members of the group?
Yes, hi, it's Nikos here. I'd like to ask a question also to George. Have you by any chance come across any innovative approach in engaging people or citizens in the way energy is consumed in buildings, as in a type of a demand response fashion? Have you seen anything innovative around that?
I've seen many efforts, but I wouldn't say I particularly liked any of them, nor that I found them innovative. But I do believe that there are ways through play and role playing and creating narratives to engage people, the users of these spaces, in such a storyline, in giving them incentives to use less energy and compete to each other.
Thank you very much. Thank you.